Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's check and see how well you did on your homework. All right, so for M&Ms, we've got volume of a cylinder, and pretty much it follows the same formula for all prisms. You've got your base. The base is what names your prism, and the circular base lets you know this is a cylinder. The base has an area, which you can find by taking pi times the radius squared. In this case, the radius appears to be 12, so we'll square that to make 144, then multiply it times pi. That's going to be the area of the base. So this right here is your capital B base area. Once you've got the area of the base, we want to kind of visualize what we were doing last year with that cake and take the very first layer of this, and there are a total of 15 1 centimeter layers. So the first layer is going to be all cubes, and it'll be the same amount of cubes as the area was, because we're just multiplying the area times 1, but we're now changing them to cubic units instead of square units. And then you multiply that times the 15, because you've got 15 of these layers going all the way down your cylinder, so on and so forth. So you take the base area, whatever your base is, it could be a triangle, it could be a rectangle, it could be a trapezoid, it can be any shape. Find the area of that base, and then multiply it times the height, and the height is the distance between the two parallel bases for your prism or for your cylinder. So this is the distance, 15 centimeters, between the top circle and the bottom circle of the cylinder. So you just multiply that times the base area times the height, and you will always have the volume. And the volume will always be expressed as cubic units, because we're counting three-dimensional units, the number of cubes that would fill up this entire space. So we've talked about how you'd find the volume for cubes to begin with. What you have to do is you have to figure out what is your base going to be. Do you want the base to be this bottom layer, which appears to be a total of 6 square units? And then you've got 1, 2, 3 layers. So you're going to take 6 times 3. There are a total of 18 cubes here. If you don't believe me, I mean, picture counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There would be another row, 13, 14, 15, 16, 17, 18. Okay, so that's if you want to have this be your base. If you chose to have this be your base instead, because with rectangular prisms and cubes, you are allowed to have anything. They're all rectangles, so any of them could be the base. If this were your base area, then that base area has 9 square units, and you have 2 layers, right? One set of 9 here and the other set of 9 there. So you'd multiply it times 2, and you get the same answer. Each time your volume is going to be 18 cubic units, depending on which base you choose to use. So when you have rectangular prisms or cubes, it really doesn't make any difference which side, which rectangle or square you choose as your base. But when you start getting into your triangular prisms and your pentagonal prisms and your hexagonal prisms and your octagonal prisms and whatever that is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, decagonal? Yeah, I don't know. But at any rate, these are always going to be your bases. So you have to find the area of this base, then multiply it times the height. You want this to be the base, find the area, then multiply it times the height. This has to be your base, multiply it times the height, and so on and so forth. Now, one thing that I'll tell you, in this chapter, we're going to be dealing with triangular prisms, rectangular prisms, and cylinders. Those will be the 3 shapes where you might have to find out the area of the base. The triangular prism is going to have a base area that is 1/2 times base times height. Remember how to find the area of a triangle. And then the rectangles are always base times height. If you have a pentagonal prism or a hexagonal prism, they will tell you what the base area is. We are not going to expect you to dissect this shape into a triangle and a trapezoid, find the two different areas, and then add them together for your base area. Not going to go there in 8th grade. They will strictly tell you that the base area is a certain number of square units, and then all you have to do is multiply it times the height, which makes actually these prisms a lot easier to solve because you don't have to do the complex work of finding the areas of the bases. So here we've got cylinders. So we know that the area of the cylinder's base is going to be pi times the radius squared. So here the radius is 5, so you're going to square that to make 25, and 25 times pi is about 78.5. So you take that, remember the overarching formula here for all of these prisms and cylinders is base area times height. So you take 78.5 and multiply it times 10, and you get 785 cubic centimeters for the volume of this cylinder. Here, you know, a shape doesn't have to be having its base on the bottom. I mean, this is the base, even though it's tipped over on its side, and this is the height, because the height is really the distance between the circular bases. So once again, take your radius and cube it. In this case, 3.4 squared. Did I say cube it? I meant square it. 3.4 squared is 11.56, and then multiply that times pi, and you get approximately 36.3 or somewhere in there. I honestly don't know. Let me just actually check this. I might have, when I created this, used 3.14 instead of using the calculator. So let's just verify that 3.4 times 3.4 is 11.56, and you multiply that times pi, and 36.3, yeah, that's what we got there, 36.3. So then you have to multiply that, that's your base area, times your height, which is 9. So when you take that, you multiply it times 9, you should get 326, all right, 326.8, because I didn't round it to 36.3. So yeah, anywhere in there is going to be good. Within a tenth or two is fine. All of these, remember, because pi is irrational, they're all rounded off at some point anyway. We have to find surface. We didn't have to find surface area, just volume. Good. Surface area is horrible. Volume is easy. And here you go. Here's an example of a hexagonal prism. And they're not going to ask you to find the area of the hexagon base. They're just going to tell you it's 62 square inches. Well, that's wonderful, because we're just going to take 62, which is your base area, and multiply it times your height, which is 12, and you're going to get 744. And since it's volume, we're counting number of cubes, so cubic inches in this particular situation. Now, I will actually kind of show you this. I want you to remember our rules. If you took x squared and multiplied it times x to the first power, how the answer would be x to the third power. Because when you're multiplying powers together that have the same base, you keep your base and you add your exponent. Well, I would say that our unit of measurement is kind of like a variable here. So if I say 12 inches, that's inches to the first power, times 62 square inches, then we're going to take the 12 times the 62, which is your 744, and then your inch to the first power times your inches to the second power gives you inches to the third power. So same idea, same concepts, same rules. That's why for cubic units, it's always inches to the third power. All right, find the length of the side labeled x in each of the right triangles pictured below. These are all examples of Pythagorean theorem type problems. So a squared plus b squared is equal to c squared. And for our a and our b are always going to, no. The two that form the right angle are the a and the b, and the c is the hypotenuse, the longest side. A and b, and this is your c. A and b, and this is your c. And remember, it doesn't matter which one of these is a or b. It makes absolutely no difference. So with that in mind, we're just going to take x squared plus 5 squared, and that has to equal 13 squared. So x squared plus 25 is equal to 169, and now we're going to use algebra to take away balanced sets. And what number do you multiply times itself to give you 144? The square root of 144 is 12, which means this side has to be 12. Same applies here, but we're going to get the hypotenuse now. So 3 squared plus 6 squared is going to be equal to x squared. So 9 plus 36 is equal to 45. So that means that x has to be the square root of 45, which is irrational, and it rounds off to about 6.7. And then here, you've got x squared plus 15 squared is equal to 17 squared. 15 squared is 225. 17 squared, I can't remember off the top of my head what that is. What is 17 squared? It is 289. So x squared plus 225. So let's take 225 away from this, and you get, what is that, 64. So if x squared is 64, then x has to be the square root of 64, which we know is 8. So I'm hoping all of you are feeling very comfortable with Pythagorean theorem. It really is quite simple, especially when you have your calculators to help you along the way. Exponent rules, here when you're dividing powers, you subtract the exponents. You could write it either way with the negative exponent, since 3 minus 9 is negative 6, so that becomes 5 to the negative 6th. Or if you were to expand out 5 times 5 times 5 on the top, and then 5 repeatedly multiplied 9 times on the bottom, when you cancel out the top and the bottom, all the giant ones, you're left with 6 5s repeatedly being multiplied in the denominator. And since you canceled everything out of the numerator, you would have just a 1. Here, this starts to get a little bit trickier because the exponent applies to what it touches. So this is touching the parentheses, which means it's going to be a to the 4th times b to the 4th in the numerator. And in the denominator, it's going to be a to the 1st times b to the 3rd. So now you can kind of separate these into their parts and do the same thing you did there, where you just subtract the exponents. This becomes a to the 3rd, and this becomes b to the 1st. Here, same idea. The exponent applies to what it touches. So this negative 3 only applies to the x, but this 2 is going to apply to the 8 and to the x. So we're going to combine the 8 to the 1st power times 8 to the 2nd power to give you 8 to the 3rd power. And then x to the negative 3rd times x to the 2nd, negative 3 plus 2 is negative 1. So if you wanted to write them with negative exponents, you write it this way. If you want to write it with positive exponents, just move this guy, remember, across the street. It becomes 8 to the 3rd over x to the 1st. Either way is fine. And then this one here, this becomes 1 over 6 to the 5th power times 6 to the 3rd over 1. Okay, so remember, when you've got fractions, it's literally going to be 1/6 times 1/6 times 1/6 times 1/6. So all the ones, we don't need to write the 1 to the 5th power because you know that's going to be equal to 1. If you wrote it 1 to the 5th power, it's not a problem. Totally okay, but it's just 1. But now you're going to have how many more? You're going to have 2 more of these on the bottom than on the top, because you're going to have 6 times 6 times 6 on the top and 6 times 6 times 6 times 6 times 6 on the bottom. So if you choose to write it as 1 over 6 to the 2nd power, you could do that. Or you could move these guys across the street and they become negatives. Most people probably would write it this way, though. Absolute value expressions. The absolute value bar is like a parentheses. It has the highest priority, so figure out what that is first before moving outside of it. So -5 plus -1 is -6 for A. Now you have to find the absolute value of -6, which is +6. -2 times 4 is -8. The absolute value of -8 is +8. The absolute value of -8 is 8, and then times 3 gives you 24. The absolute value of 8 is 8. Then you multiply it times -3, you get -24. Here, you end up with, let me go ahead and show this one, 5 minus -5 plus 10 is +5. So this becomes 5 minus the absolute value of 5, which is 5, which is how you get 0. For the last one, for this last one, we got 6 minus 10, which is -4. But the absolute value of -4 is +4. Is that it? Oh, we got one more. Okay. All right. So here we've got some interest problems. Tim wants to invest some money that his grandmother gave him. He has $2,000 and can put it in an account with simple interest or an account with compound interest. All right. Well, if they're going into the accounts that have the exact same terms, we know compound interest is going to grow more quickly than simple. But if they change the terms, like for instance, they both appear to be 5 years, but the terms, the simple interest is 10% and the compound is 8, which means this is going to grow more quickly early, but then this one's going to compound and eventually will surpass it. So we've got two different formulas here to work with. You've got the simple interest formula, which is I equals PRT, and then you got the compound interest formula, which says A is equal to the amount of the principal times 1 plus R raised to the T power, being the number of times it's compounded. So since this is being compounded yearly, our time in this case is going to be 5. Our interest rate is 8%, which when you add it to the 1 becomes 1.08, since 8% is 800ths. And then the principal, I believe, was 2,000, right? 2,000, yeah. Okay. This formula is going to give us the amount after 5 years. This formula is going to give us the amount of interest earned after 5 years, which we would then add to the amount. So the principal was 2,000 at a rate of, I believe it was 10%. So in decimal form, that is 0.1, and then that is for 5 years. So 10% of 2,000 is 200, and that's the amount that he would make every year for 5 years, means that he is going to earn $1,000, which when added to the original 2,000 means he will have $3,000 after 5 years. How much will he have after 5 years at 8% compounded? Well, let's use our scientific calculator here. Let's take 1.08 raised to the power of 5, and then multiply that times our $2,000 principal, our investment, and you get 2,938 and 65, that rounds up to 66 cents. Okay, so in 5 years, the simple interest, because it had the higher interest rate, is still going to be making more money than the compound interest. But I'd be willing to bet after the 6th year, where this would be 1,200, let's see, 6 years will be 3,200, because that's just increasing by $200 per year. That's a proportional type of a situation. Let's see what this ends up being after 6 years. Just curious. 1.08 raised to the power of 6. And I'll multiply that times 2,000. And still, after 6 years, the simple interest is a better deal. I could bore you guys to tears by continuing with this. It's not important. But at some point, I guarantee you, this is going to surpass the simple interest. Even though it's got a lower interest rate, because it's compounding over time, it's going to grow and go beyond the simple interest rate. All right, and I believe that is it for today. Thank you so much. I've got a check for understanding for you to take a look at, and there are also some Khan Academy videos on finding volume of cylinders. I think, unless I already gave it to you, I can't remember. Today may end up being an easy day. I'm not giving you a new lesson. But we will have an assessment tomorrow, so make sure that you review how to find surface area and volume of cylinders. All right, take care.
Hey, feeling good, like I should. When in dark, walk